Hey guys, so in this video I'm going to be talking about word problems with percent applications that have to do with mixtures. And when I say mixtures, so this can mean a lot of different things. So this could be things like mixing, I don't know, metals, chemicals, funds or money or anything else. So it's really whenever you see two percentages being mixed, this is the general way you can think about them. So it doesn't really matter what it is that you're mixing, okay? That like sometimes people think, oh, it matters if I'm mixing a chemical or money. It really doesn't. It's just mixing up percentages. So let's take a look at an example here. So I've got money. So Lala deposited $500 into a simple interest account that paid 7% interest per year and $1,500 into another account that paid 9% interest per year. After 1 year, how much interest did she make? And then what is the total amount, or what is the total percent of interest earned on the two deposits? Okay. So this question is interesting because there's a lot of different ways that you can kind of spin it. So we have first just the idea of interest on two different accounts. And so we're being asked how much interest did she make? So that would be how much did she make over this amount of money? So that question's a little bit simpler than the second question, which is what total percent of interest was earned on the two deposits. So I want to show you kind of two different ways to break this down. So let's start by just thinking about this part. So I don't want to worry about the other part right now. So I'm just going to put a 1 next to this so that you know this is the question I'm talking about. Okay. So the way that interest works, so you have really the interest from one account plus the interest from the other account, and that's going to equal your total amount of interest. So that's like a straightforward idea, really. And notice when I set this up, so I'm all about always figuring out where does the equal sign go and kind of the basic structure. So here's kind of the basic structure. So interest after 1 year, it's always just going to be the amount of money that you put in times that percentage amount. So to set this part up, what I'm going to do is I've got the interest, the 7%, not 5%, 7% interest on $500. That would be the setup for this one. And then I have the 9% interest, can't write today, 9% interest on the other account. And that's going to give me the total interest that I'm making. Okay. So this is just a nice straightforward calculation. So let's do this. So 0.07 times 500, so that comes out to 35. And then 0.09 times 1500, that comes out to 135. So in total, we get $170 in total interest. Okay, so that's the first question. That's how much interest she made from both accounts. But now we want to pivot to this other question, which is what is the total percent of interest earned on the two deposits? So what this is really getting at, if you're not sure, so if I combined these two amounts, the $1,500 and the $500, and I know that I get $170 in total interest, what is the just singular percentage then that was applied to this amount of money, the $1,500 and the $500. So let me clear some space. And I'm going to show you the absolute most general way to think about this, which is not the same as the fastest way to think about this, but there's a pattern here. So I kind of want to establish the pattern so that you can see it over and over. So the idea behind this then, so I'll mark this with a 2. So now we're thinking about the other question. So I have the interest from the first account, and then I have the interest from the second account. And so in this case, I want to figure out from this, how do I get the interest rate really from both accounts? So this is just a slightly different way of thinking about this. So I want to, maybe this isn't the best way to think about that. Maybe I'll say the interest rate between both accounts. Okay, so the setup here is literally the exact same. So it's still going to be this 0.07 times 500 and then this 0.09 times 1500. But the thing I'm trying to figure out is how do I get to this interest rate from both accounts? Well, in this case, I really want to think about this just like interest. So I want to think about this as some mysterious rate that I don't know. So we'll call that rate X. And that's going to be X times the total amount of money. So that's how I get to the both accounts. So I'm going to take this 1,500 and this 500. So 1,500 and 500. So there's how I can figure out the interest from both accounts. Now, we already did this math over here, right? So this was 170. So I know I made $170 off of the interest from both accounts. So what interest rate would that be then on just the $2,000 in general? So basically now I have to just solve for X. So I can divide both sides by 2,000 like this. So I get X equals 0.085. So what that means then is the total interest account, or the total interest rate split between the two accounts, it came out to 8.5%. Okay, so I want to also just mention here that this actually makes sense, and like why does this work, or how do you have a intuition if it's right? So 9% was the higher interest amount, and that was used on more money, right? And then $500, that was on the lower interest amount. So you're not going to expect the total interest amount for both accounts to be as high as 9%. But since most of the money was in that 9% account, you would expect that it would be probably close-ish to 9%. So the fact that this is pretty close to 9% but not 9%, that intuitively feels right. So you can take a moment just to kind of think about, does the answer actually make sense? Okay, so now I want to talk about a different type of mixture. So, okay, I've got Steph works at a coffee shop and she's mixing coffee roast. So the breakfast blend contains 20% of the beans from Colombia, and then she mixes 3 pounds of the breakfast blend with 7 pounds of another roast that is 100% pure Colombian coffee. So how many pounds of this mixture contain actual Colombian beans, and what percentage of this new blend contains Colombian coffee? So these are two different questions, but this is actually like the same idea from before. So instead of talking about money, I'm talking about coffee pounds, but it's the same idea. So it's still, I have a percentage here and a percentage here, but now instead of it being a percentage on an amount of money, it's a percentage on a type of coffee. So don't get hung up on, oh, I have to do this technique with money problems and this technique with, coffee problems. It's literally the same. So let's talk about how to set this up. So first question I want to get to is this one. How many pounds of this mixture contain Colombian beans? So let's reread this. The breakfast blend contains 20% of the beans from Colombia. So she's got 3 pounds and 20% of that are going to be the beans from Colombia. And then she's got the other amount, 7 pounds, and that's 100% from Colombia. So I'm going to set this up literally the same amount. So I've got the percent of beans in the breakfast blend plus the percent of beans in the 100% roast. So it's just kind of showing me how to set this up. And this is going to give me the total amount of Colombian beans. Okay, so let's set this up. So the first one, it was 20% of the 3 pounds. So there's my 20% of the 3 pounds. Now for the other one, it's going to be 100% of the 7 pounds. So I know it looks a little ridiculous to write the 1 here, but I wanted to show you this is a very consistent way of thinking about this. And this is going to give me, again, my total kind of Colombian poundage here, I guess. Okay, so look at this. Let me flip back to the last problem. In the last problem, we were doing the percentage times the dollar amount, plus the other percentage times the dollar amount, and that gave me the interest. Now here, I'm doing the percentage times the pounds, the percentage times the pounds, and now that's just giving me a different piece of information sliced a slightly different way. So it's literally the same idea, and that's a really important thing to kind of think about, because I think as you read these, you want to just really view this as it's just a mixture. and it doesn't really matter what you're talking about. So if I set this up, I'm going to have 0.6 plus 7, and that comes out to 7.6. So this will be 7.6 pounds of really Colombian beans. So in these two roasts that we're combining, I will end up with 7.6 pounds of the Colombian beans. Now, I want to figure out between the 3 pounds and the 7 pounds, so after I combine these, what is my new percentage of Colombian beans when I combine the two roasts? And that's the same idea as what was the total percent of interest earned on the two deposits. It's literally the same idea with this same setup where you're interested in what is this interest rate that you're applying between the two accounts, or now in this case, the two mixtures of coffee. So I'm going to now focus on this part here. So let me make some space. Okay, so I'm literally recycling this from before, and I want to figure out how does this give me now the percent of Colombian beans on the total mixture. So, all right, I've kind of abbreviated this here. So this side is still set up the exact same. So it's still going to be 0.2 times 3, 1 times 7. But now the one thing that I want to just change here is I want to also represent that I have some percentage. I don't know what that percentage is, so I'm just going to call it X for now. That percentage on the total amount of coffee, which the total amount was 3 pounds and then 7 pounds. So I combine those two amounts. So I know what this comes out to. This comes out to 7.6. So I have 7.6 equals 10x. And then once again, so I can just divide both sides by 10 to get that this is 0.76. So what this means is after I combined these two roasts, the 3 pounds of the breakfast blend and then the other amount of the just pure Colombian coffee, what that gave me now is a mixture of coffee that is 70% or 76% Colombian beans. So I've got 76% of the Colombian beans. Okay. So now let's pivot to another mixture. So this one's like more explicit mixture, but it's still the same idea. So Larry has mixture A with 55% acid and mixture B with 12% acid. And he has 200 milliliters of mixture A. So how much of mixture B did he use if his new solution is 48% acid? So this one has a little bit of a plot twist, but the idea behind the setup, it's still the same, but there's going to be a few tweaks. So the first thing I want to think about is I just want to have the percent mixture of A plus the percent mixture of B. And so now notice that in this particular problem, we're being told what the new solution, when you combine the two amounts, what percent, like what the total percent acid is. So what I'm going to have then is the percent mixture of both A and B. Okay, so this will be a very similar setup. So let's first think about, so of this first mixture, what amount of it is actually acid? So I know that 55% of A is acid, and I know that it's 200 milliliters of mixture A. Okay, now mixture B, I know that mixture B is 12% acid, but I don't know how much mixture there is. So what letter should I give this? We will give it B just to make it clear. Okay, now the last part of this is I know that the new solution is 48% acid. So this is going to be 0.48. And what goes inside the parentheses here? Well, you have to combine your A and your B. Now I know how much was in A, but we already said we don't know how much is in B. So you're just going to add those two things up. Okay, so now if you just take a step back and look at this, you'll notice that we have really a problem where we have to solve for B. So let's go through and work this out. So 0.55 times 200 will be 110. And then I have this 0.12b. And then that's going to equal 96 plus 0.048b. Now, I've also talked about in other videos how you can get rid of decimals. So if you don't want to deal with the decimals, remember you can always just move them. So I want to move all of the decimals 2 spots over, but if I do that for the decimals, I also have to do that for the whole numbers. So I've talked about this technique in other videos. I will drop a link to it in the comments if you want to see that video. Okay, so I got rid of all the decimals, which makes me happy, makes some people happy. So now I can just go ahead and solve this as usual. So I'll go ahead and I'll subtract off the 9600. So that will come out to 1400 plus 12b equals 48b. And then let's see, I'm kind of running out of room here, but I'll just squeeze this in. So I get 1400 equals 36b. And then if I divide both sides by 36, I get that b equals about 38.9 milliliters. And so that would be the answer that we're looking for. That's how much of the mixture B we had. But this is still the same setup we've been using, right? It's just now we had a new letter that we kind of inserted into this. Okay, so hopefully now you're starting to see kind of how some of these can play out. So let's take a look at one other example. So a company owns 2 different factories to make furniture. Factory A produced 2 times as many dining chairs as Factory B. 5% of the chairs from Factory A and 3% from Factory B were defective. How many chairs did Factory B produce if 770 of the chairs were defective? So we still have a mixture here. This one's definitely a little tricky, but the first thing I want to do is I just want to think about what's the general structure. So we're talking about really defective chairs, and we have this percent, 5%, and 3%. So I know in this problem that the amount of defective chairs from A plus the amount of defective chairs from B, those come out to 770. So these amounts are going to be those percentages times the total amount of chairs that they make. Now this might be a little tricky, so we can take this in steps. So I can think of this as 0.05, and then I've still got to figure out what are the chairs from A, because that doesn't tell me. And then I've got the 0.03, and this is going to be the amount of chairs from B, and this is still going to equal 770. Okay, so now here's the tricky part. So I have to reread this one more time. Factory A produced 2 times as many chairs as Factory B. So this is the other big thing you want to look for in a word problem is when are quantities defined in terms of other unknown quantities. So this sentence, to me, I don't know how many chairs Factory B made. It doesn't say. But it's telling me how many chairs Factory A made in terms of Factory B. So that actually kind of helps you whittle down the problem. Since I don't know how many chairs were made from B, I'm going to call this just B right here. So I can fill that part in. And now, to figure out the chairs from A, well, the one thing I know about them is that it's 2 times as many as B. So how do I represent 2 times as many as B? It would be 2 times B. So this will be this times 2B. That is how you actually represent the chairs in that case. And so now we can solve this as usual. So now you can see where the B is, and you can kind of go from there. So let me make a little space. And one last comment before I keep going with this, in case you were wondering, why didn't we set up a percentage here? So it all has to do with what the problem asked for. In this particular problem, nowhere in the problem does it ask what was the total percent of defective chairs. it doesn't care about that. In the last problem, it did care about that. So it all depends on the context as to how you're going to make kind of this part of the problem look. So in the first two examples that we did in this video, you know, we looked at both different ways to structure this, and hopefully now it's kind of starting to make more sense. When do you do the total percentage times the total amount, and when don't you? But if not, you can feel free to leave me a comment, and you know, if I have to make more explanations, I can do that. Okay, so I'm gonna go ahead and multiply these things out. And so then what I get is 0.13b equals 770. So you can either move the decimals or not, but I'll just finish solving this as is, but you can use that good old decimal trick if you so desire. So this will equal 5,000, let's see, terrible looking 5,923.08, which I'm just going to round up to the next whole chair. So this is how many chairs that B made. So that's what it asked, right? How many chairs did factory B produce? This would be how many. Okay, so that covers it for this video. So I know this is definitely a tougher topic. Like I said, if you have questions, you can feel free to leave me a comment. And if I need to make more videos, I can always do that. Or if you have questions or you just general things for your understanding, feel free to leave me a comment. Thanks for watching, guys. I'll catch you next time.